Okay, welcome to Chapter 8. This is a chapter dealing with user interface design. It's the first of 3 chapters in the design section, the blue section in the book, and talks about the system design is a third of the 5 phases in the SDLC model, and you'll work with a physical design that meets the specifications described in the system requirements document. And your tasks are going to include things like the interface design in Chapter 8, the data design in Chapter 9, and the system architecture in Chapter 10. And the deliverables, when you're done, is essentially the shopping list. I mean, you know, if you were buying a new system, it'd be a shopping list. Okay, I'm going to go through the chapter objectives like I usually do. So on page 298, it says, explain the concept of user interface design and human-computer interface. Explain how experienced interface designers perform their tasks. That's a cool one coming up in that. Describe the rules for successful interface design. And discuss input and output technology issues. Design effective source documents and forms. Explain printed output guidelines. Describe the output-input controls for security. And explain modular design and prototyping. And once again, there's that preview code on case on page 299. I really like those things. Go through them. Okay, so on page 300, they talk about the 3 goals. And essentially, come on up here, you goofy little cat. Now, I'm trying to do a video, okay? Now, you're going to have to just step aside and let me do my thing, all right? Now, come on. The 3 goals. Okay. So you're basically trying to determine if you're effective, and you're effective if it supports the business requirements and meets the needs of the user. We've talked about this a gazillion times about has to be a legitimate business need to do something, and it's reliable if it handles the input errors and processing errors and hardware problems and network unavailability. So that's a kind of a third one. And then it's maintainable. You know, if it's flexible, you can add additional capacity or scalability, those kinds of issues. So effective, reliable, maintainable, the 3 goals. Then there's some talk about will it succeed? You know, what's a good measure of success? Or what's the track record for the success for a useful user interface? And so they have some cool little rules here. They talk about think like a user. Don't design the system like a database. Don't design it, like a programmer. Design it like the user is going to be using it. You know, talk about carefully examine any point where the user has to make a choice or to provide input. The user interface has got to be easy to learn, otherwise, you're going to have a lot of problems. And that input processing should be, easy to follow, straightforward, and you should be able to anticipate future needs for this thing. Maybe leave enough room on the input form for perhaps some additional fields or 2 that might pop up in the future. Don't cram it so full that there's no room to add anything later. And of course, flexibility. The best design strategies offer alternatives so the users can decide what works best for them. For example, you could have display something in text, or you can display it in a grid format, or whatever the heck they like. Provide them flexibility to make their job easier, not making your job easier. And of course, start with default values that if you're filling in a form and the answer is almost always red, well, go ahead and fill in red and allow them to change it to blue if that's not the case. They talk about managing data effectively. The system should enter and verify the data right then in one process. The rule is identify errors as soon as practical. You guys know what I'm talking about. You've been to a web form, like you're ordering something or you're filling out a questionnaire or survey on the web. And so it's got a gazillion. You have to boxes and you're filling them out. And then you hit the submit button and it comes back and says, oops, you forgot to fill out this. And you go, oh, dang, where is it? So finally you scroll up and down and find the missing box, and then add the data to it and go on about our business. How much better would it have been if the system could have told you immediately, as soon as you skipped past that, it could have come back and said, whoa, you forgot to fill in the state box. Rather than wait and say, aha, gotcha. Why not have a situation so it prompts you immediately saying, oops, you forgot something, rather than waiting to the end and saying, no, you made a mistake. So preventing errors and catching errors earliest is one of the golden rules. Okay, so every data item should have a type, if it's numeric or character, that kind of stuff. And you should collect the data as close to the source as possible, and possibly even, in other words, don't have a worker fill out a paper form that they turn into someone else who transcribes a paper form into a data system. That's too far away. Because if they made a mistake, the worker who filled out the form is not going to even know about it until the next day. But if the worker had a portable data terminal and they filled out the data right then and then, they made a mistake right there, he would know it within 5 seconds rather than a day. So if speed and accuracy is important, you do source data automation. There are some things you can do in source data automation to take the pesky human completely out of the equation. Barcode readers, those kind of things, where they don't have to type any complex numbers. They can just swipe a card or do a wand or something to help improve data accuracy. Okay, on page 301, they talk about kind of how things have changed over time. That in most cases, the system designers are kind of aware that people like certain things and don't like certain things. And they actually allow the users to kind of design, so to speak, their own user interface. Tweak it the way they want it. They want to turn this feature on or turn this feature off. Those kind of things. Make it malleable enough so the user can configure it to suit their needs. And centralized IT departments no longer produce reams and reams of printed reports to hand out to people. That people print what they want, and they don't normally print an entire report or an entire listing of inches of paper. They pick the 1 or 2 records that are of interest to them, and they produce the report themselves, rather than some batch process back at the computer room. And then, of course, the user interface has evolved. It used to be that the only user interface there was a keyboard. That was it. You had no other way of doing it. Keyboard and a mouse. Now, of course, the options are endless with, voice recognition and hand and gesture motions, those kind of things that are kind of cool. Okay, on page 302, they talk about what is a user interface. Now, we often say graphical user interface, but that's not the only one there is. It's just GUI, graphical user interface. GUI is probably one of the most common terms that's being used. So user interface is basically the candy coating on the M&M. It's the thing that the user actually touches. So if they can touch it, it's part of the user interface. If they can see it, they can taste it, they can touch it, that's the user interface. The stuff on the inside, that's not the user interface. So going back to like that case, the use case study where you drew the little system diagram limit around the outside edge, all the little stick figures pointing to that rectangle is the user interface. That is the only way they can do input to the black box or get output out of the black box. So user interface is that kind of a thing. There is an entire science on human-computer interface, HCI. And a lot of it kind of deals with metrics. For example, you probably have installed some piece of software, particularly like a Microsoft software, and during the install it'll come up and say, would you like to participate in the customer improvement program? And it reads it and says, we're going to anonymously gather data on how you use this product and send it back to Microsoft. And if you click a little check box when you installed it, it's going to look to see how you're using things, how often you use menu items and things of that nature, and send that data to Microsoft. So that's very good data they can use. For example, later on we're going to talk about like where do you put items in a menu. Well, if I don't know what is the most popular menu item that's going to be used, I don't have a clue, I could turn on a feature like this? Well, it'll record for the first month. It'll record all the menu items that gets selected. And I'll say, aha, this one gets selected the most. This one, 90% of the time, they select this menu. Well, if that's the case, I'm going to move it to the top of the list of items that you can select. So I'm going to sort them in order of use. But if I don't know what order they're going to be used in, you have to kind of instrument or go around and ask people. Anyway, so human-computer interaction is a pretty fantastic field of endeavor to get involved with. It's kind of cool. Okay, so this on page 305, they talk about the 7 habits of a successful interface designer. And there's some pretty cool stuff. The number 1 rule is you got to know the business. You got to know what it is they're doing. You got to know what this user interface is for. Because if you don't know what it's for, clearly you're not going to be able to design an interface that's going to be useful. So you got to understand the business functions, how it supports, the divisions, and how the layout of the company. You need to know an awful lot about what's going on. The second one is maximize graphical effectiveness, and it's fairly common sense that users can learn easier in a graphical environment. They learn visually, rather than reading things. And so if you make things consistent, with the same kind of little graphics, you can end up with a system that people can just pick up immediately and move on. And then, of course, think like a user. We talked about that, about making sure that you look at it through the eyes of the user and don't use terms that make sense to you but not to them. It's very difficult to get a programmer to write English. They tend to write jargon and acronyms and all these other kinds of things. So it takes almost a different kind of mindset to write, a help screen, for example, that really is helpful. And of course, you understand their experiences. It'd be kind of cool, like I said, if you had some instrumentation you could kind of watch to see how they use things. So find out what their knowledge and skill levels are, and hopefully experience with some previous systems. I mean, if they like using mice or they don't like using mice, or you can go to a little industrial kind of a scenarios and just look how dirty the keyboard is and go, okay, I know what they use and don't use. Number 4 is use models and prototypes to kind of mock up a user screen and ask for people, is this what you had in mind? Is this useful? Do you want me to move this from over here? Very detailed kind of questions you're talking about on how to get exactly what they want. And of course, focus on usability. It may not be efficient from a programming perspective to do something in a particular order, but from a user perspective, because they logically think that these things occur step 1, step 2, step 3, even though behind the scenes that's not the order they occur, do it the way they expect from a user interface design. Don't create an artificial order that's mandated by some computer geek. Make the order of the flow match what the user is expecting. And have reasonable choices, kind of make things make sense. Perhaps an opening screen that reassures them that they actually started the right application. You could have several applications that look very similar, and you could get in a situation where somebody clicks on something and it might take them, a minute or two to realize, I'm not even in the right application. Okay. Number 6 is invite feedback. I had a developer that worked with me 10 million years ago that had a regular traditional Windows application and it had a help menu button. And when you hit help, they had a little thing that said, send me feedback. And one was for report a bug. So in his application, you could send a little note, and you could just send a note to him saying, I didn't like the way this worked. Or submit a bug saying, I ran across something. So make it easy for them to provide you feedback. If you make it difficult, obviously they won't do it. The easier you make it for them, the easier it's going to be on you to update these things. Okay, we're coming up to the 15-minute mark, so this is probably a good place to start, and we'll pick it up again in just a few.